This is Calculus BC Unit 4 review. First thing we're going to do is we are going to change the first problem. I want it to be the integral of 1 over x squared minus 2x plus 2. So in order to find this, we have to complete the square. So we get the middle term, divide it by 2, and square it. So that is what I'm going to add. But in order to make the equation equivalent, and then I need to subtract 1 as well. And that just means that I just added zeros, because 1 minus 1 is 0. So I get x squared minus 2x plus 1 plus 1. So if I complete the square, if I factor that, I get x minus 1 squared plus 1. So this is our tangent. Remember, the integral of arctangent, the integral of 1 over a squared plus u squared is 1 over a arctangent of u over a. So in this case, u is x minus 1 and a is 1. So my integral is going to be arctangent of x minus 1 plus c, which is arctangent of x minus 1. For b, notice that it's very similar to our a, so this is also arctangent. U is going to be x plus 1, and a is going to be 4. So my integral is going to be 1 over 2 arctangent absolute value of x plus 1 over 2. The next problem asks us to determine the area bounded by the graph of y equals 0, x equals negative 1, and x equals to 1. So if we graph it, we end up with this figure. So the area from negative 1 to 1, so we're looking for the area of this. We're going to make a vertical strip and find the area of that. So it's a small change in x. So I'm going from negative 1 to 1 of the top minus the bottom dx. So one of the things is you need to be able to do this without using the calculator and using the calculator. But using the calculator, we end up with 1.708. Without the use of a calculator, you need to remember that this is arctangent of x. The next problem asks us to find the volume of the solid generated by evolving the region bounded by y equals square root of 2, y equals 2, and y equals 0 about these different methods. So first thing we're going to do is graph it. So y equal to 2, and x equals to 0. So we are looking and this point here would be 4, because when y is 2, x would be 4. So we're going to rotate it about the x-axis. So as we rotate about the x-axis, we're going to have a dx, and we're going to have a washer. So big R is going to be the top minus the bottom. Little r is going to be the top minus the bottom. So my integral is going to go from 0 to 4, 2 squared minus the square root of x squared dx. So my antiderivative would be, and don't forget that it's also times pi. It's going to be 8 pi. So that would be my volume. For part B, we're going to rotate about the line y equals to 2. So we are going to rotate this way. So we're still going to have a dx, but this time we're going to have a this. So I'm going to have pi from 0 to 4 of the top minus the bottom squared. This is my radius, dx. And I get 2.667 pi. For part C, it says the y-axis. Let me go ahead and try it again. Now we're going to have the y-axis, which is a dy. So what we can do is we can switch, solve for x. Since we have a dy, we want our variables in terms of y. So we're going to have a this, and there's my radius. So my radius is going to be y squared minus 0. The right minus the left. So instead of going from 0 to 4, I'm going to go from 0 to 2, because everything has to be in terms of y. So y squared, my radius squared dy. And my volume is 2.667 pi. Don't forget that it was also pi. And D is the line y x equals negative 1. So we want to rotate it around the line x equals negative 1. So we're going to have a dy. So this is going to be a washer. So big R is the right minus the left. So it's y squared minus negative 1. Little r is the right minus the left. So 0 minus negative 1. So my integral goes from 0 to 2 of big R squared minus little r squared dy. So that's 11.733 pi. next problem says consider the region bounded by the graph of the equation y equals x square root of x plus 1 and y equals 0. So if you graph this using your calculator, you end up something like this. And y equals 0. So then you go, well, there's no area bounded. So this is where you need to be careful when you graph it using the calculator. If you zoom in on your calculator, you end up with a little bit bigger so you can see it. You end up with something like this, where this is -1 and this is 0. So the area bounded by these two graphs is right here. So the first one says I need to find the area. So it's going to be -1 to 0 of the top minus the bottom. So that's just the integral from -1 to 0 of negative x square root of x plus 1. And that turns out to be 0.2667. Part B, we want to find the volume of the region which we revolve around the x-axis. So if we revolve around the x-axis, we're going to have dx. So this is going to be a disk. So r is going to be the top minus the bottom. So I'm going to go from -1 to 0 of the radius squared. So I end up with 0.0833 pi. Part B asked me to revolve it around the y-axis. So I need to have everything in terms of y. But this is going to be really hard to solve for x because I end up with the square root. So what I'm going to do is I'm going to use the shell method. And the shell method says that I can, since I need dy, I can do it in dx. I need to have my height perpendicular to the axis of rotation, and my radius starts from the axis of rotation to my height. So the height is going to be -x square root of x plus 1 because it's the 0 minus x square root of x plus 1. The radius, notice that I'm going to the left, so it's going to be -x. So it's the right minus the left. So the right minus the left. So that is just and my radius is going to be -x. So I'm going to have 2 pi from -1 to 0 of -x square root of x plus 1 times -x dx. And that ends up being 0.30476